All right. Good morning, everybody. Welcome to the front-end app sync for Subspace. We're going to be diverging a little bit from our normal call today since we're working on getting the relayer finalized for the Aries testnet. So we're going to talk about that some first, and then we'll get into our normal front-end apps discussion. So to start out, I want to review the high-level architecture for how all this fits together. And discuss that, answer questions as a group to make sure that we're on the same page. And then we can talk specifics about the latest steps, Serge, on the relayer progress. And Nazar, we can talk about the backup progress as well for the existing parachains. And then we can go into our front-end apps discussion from there. Okay. So I'm going to share my screen. If you guys look in Lucid under the Relayers tab, I've created this diagram here. There's a lot in here, but it's up at the top now. There's this diagram that tries to map out the architecture here of what is actually happening. And it's a little bit complicated, and we're going to try to simplify this. At least we're going to try to get people on the same page as to what's happening. So just as a quick overview, this is the workflow of getting all the data for the parachains. So like for the Kusama relay chain and the parachains, getting the initial history of that data, seeding the blockchain with that data, and then starting a node with that data. I guess seeding it, starting the node, and then opening that node up to the public, and then getting other nodes on the network that are actually going to, like other farmers that are going to go ahead and plot and store this data. And it turns out that there's actually some challenges and issues here. I just want to make sure everybody's aware of and how we're handling those. Okay. So if we follow along on the left here, the first problem we have is when we start the network, all these parachains in the Kusama relay chain have been live for some time. And we're saying we don't want to sync from the network because that's going to take a really long time. We want to preload the history and then do some accelerated block production to store this state. Okay, so but the question is, where do we actually get this history from? Okay, and how have we been doing that up to this point? Well, Nazar has been getting it on his machine locally. Okay, so he's calling an RPC endpoint for a source chain, which could be a parachain or the Kusama relay chain. In some cases, he's running a full archival node for the parachain. In other cases, he's requesting it directly from the on finality public, or even in some cases the private API. We've been trying both of them. The problem with this, if you're a parachain, you have to run a Kusama archiver node as well, or a full node for Kusama. So you're so if we have 12 parachains, that means Nazar's backing up Kusama 13 times on his machine, which is insane. And so this is just, it seems to be the way that you're meant to run a parachain. You have to run a relay chain node on top of it to sync. Maybe there's some shortcut or hack to prevent this, but we haven't been able to figure it out. So that's why we were trying to sync from on finality as well, or instead rather. Does that
Let me clarify a little bit. It's actually it seems to store a little bit less data, like 5 times less than the full relay chain. But it still stores tens of gigabytes of data for relay chain in addition to the parachain itself. And the primary reason why I'm using on finality for some of the chains is because I just can't run the node for them. Like either instructions are broken and Docker image is not working, or it doesn't sync the parachain blocks for some reason. So I just can't get the data.
Okay. Okay, so we're getting the data. Where is it going? So we were originally doing it directly on the file system. There were issues with that. So now we're doing it in a RocksDB database. So we're running a different RocksDB database for each parachain, for each source chain. And Nazar is literally taking the folders, like the storage folders for those databases where they're saved on disk, and he's creating torrents for those. And then we have to get that into a DigitalOcean droplet. So there's like a volume on DigitalOcean where we're just replicating these folders, okay? These folders for the RocksDB databases. So there should be 13 folders on here eventually, one for the relay chain and then 12 parachains, I think is our last count. So in some cases, this is in like, and this is in progress, so we don't have all these on BitTorrent yet. Actually, how many of these have been created so far, Nazar?
I only created for Kusama, but
Okay.
I can create for like 5 more.
Okay. So in some cases, Nazar is just directly uploading these from his computer. In some cases, they're in BitTorrent, and if you need to retrieve them, you can for like local development purposes, like Kusama being the main one. But it's large. It's like 35, 40 gigabytes for the Kusama history right now. Okay, so and this has not been created, right, Nazar? We don't have a separate volume for this database yet, or for these folders.
There is. I just didn't move the data yet.
Okay, so we've created a volume for this, but the data is not on there. So right now the data is on the same volume as everything else for the Bootstrap node. So we also have the relayer itself, okay, which is a node, and it's also in Node.js. That's confusing, right? And that is ideally should be an independent node, independent process, but right now it's kind of all running on the same machine. So we have the relayer node, we have the Bootstrap node, and the Bootstrap node has a second node, which I didn't realize until yesterday from talking to Nazar, that exposes a public RPC endpoint for it. So we actually have 2 nodes, 2 substrate clients running on the same machine. If the relayer is on a different machine or a different instance, different DigitalOcean droplet, then it's going to have to connect through this endpoint. If it's not, if it's on the same instance, then it can talk directly to the Bootstrap node. So that depends on how we set this up. Okay, this would be preferred at Genesis, at startup, because it's like less round trips, right? Like the whole idea was of the startup was to have direct connection without like any kind of network delay, even if that's local network delay, to prevent like edge cases or race conditions or something like that in the ordering of the transactions. Because we're literally reading like Kusama block 0, put it in a transaction, Kusama block 1, put it in a transaction, like keep doing that until we fill up the block, and then submit all those to the Bootstrap node, and then it should produce a block. So another thing that's important to understand is like how much data are we talking about here? We're estimating, we don't know the full answer yet, but we're estimating something like 75 gigabytes for Kusama plus all the parachains. So that means that we have 75 gigabytes of object data, effectively, that we're uploading into our blockchain. And there's going to be some overhead, right? There's like transaction metadata, block headers, consensus data that all gets on top of that. So maybe like, I don't know, 80 gigabytes is what the actual archival database is of our blocks, because this is an archival node. And I guess this is actually, I think this is replicated twice. Is that right, Nazar?
Exactly.
Yeah, okay. So this is 80 gigabytes, this is 80 gigabytes. And then this node also is running a farmer. So this is 2x, right? Because we erasure code. So this is 160 gigabytes. So we have something like 320 gigabytes here, plus this volume. So we're like, I think you guys might be getting the point here. We're starting to see some duplication of effort here. And then the other thing is, okay, now I want to spin up another node. Okay, so let's say that like, you know, you spin up a farmer or like you want to join the network, let's just say a farmer, the first thing you have to do is sync this. All right, you have to sync the history. That's 80 gigabytes of history you have to sync. It's an open question how long that will take. It could take days for anyone joining the network. As you grab that history, you're also going to be plotting it. Basically, as you pull each block, you're going to create you're going to run the archiving process, and then you're going to create your own plot as well. And you're going to end up needing about 240 gigabytes of space. Any farmer is going to need about 240 gigabytes of space to run this, because they're storing the block database plus the plot, which is twice the size of the block database. Now, eventually, we're trying to delete this, right? We're trying to make it so the farmer doesn't store the archival history. That's the network's job. And this will get better, but that has not been, that's part of the upgrade path, right? That hasn't been implemented yet. So we're kind of duplicating our effort for now. But like, just keep that in mind. If you're running, like before, when you ran a node for Spartan, it was just using like the 1 gigabyte that you told it to use, and the blockchain was tiny. Now it's using a lot of space to run a node. And this might actually, and it's going to take a long time to sync the history. So these are some challenges that we're going to have to deal with. The other really critical challenge, which we're going to need to deal with like immediately, is how long will it take to upload? Like once we have this seed database and we're starting from Genesis, the relayer has to upload all this data into the Bootstrap node, okay, to start. And we're going to assume that on the initial network, there isn't any of this, right? We're just going to have the Bootstrap node, and we're going to maximize the size of these blocks. So we did identify that the max block size is, where did I put that? It's not in here. Okay, the max block size is 5 megabytes. So if you do the math on that, 75 gigabytes of data, 5 megabytes per block, we're looking at roughly 15,000 blocks that we need to upload this Genesis history. And we have a 6-second target block time. Now it's going to start with faster blocks, but we also have this work difficulty that's taking into, or the solution range resets that are taking effect, and they run every 2016 blocks. So that means pretty quickly we're going to be at a 6-second block time. It's still going to deviate, because we're growing the history, but it's going to stay pretty close to 6 seconds. And I think we ran the math on this, and this was going to take like a day, like 18 hours, maybe more, to upload. So that means every time that we have to restart the test net, we have almost a day of just running this node in isolation just to seed the history before we can have other nodes join the network. So the sort of hack, the fix that Nazar and I identified for this is we're just going to disable the work difficulty resets, or the solution range resets, until we hit some predefined target, which is like 15,000 blocks in this case. So that's going to speed it up. It's not going to make it, it's going to be like maybe 4 hours now, which is still not great. We'd want it to be like maybe 30 minutes, or like limited by the disk somehow, but it's better. 4 hours versus like a day. So that's like a quick way to do this. But again, like, the important thing to note, like, so we're saying, well, we're going to start with Kusama, then we'll add the other parachains as we add support for that. So every time we do that, we're actually going to have to restart, like redo this whole process. So like when we get Kusama working great, we find a bunch of bugs. I'm sure there will be bugs. We'll fix the bugs, and now we're ready to add support for parachains. Well, now we have to start over. We have to basically start over from Genesis and reseed. And that seed database needs to store all these parachains, because again, we've said if we sync over the network, it's going to take a very, very long time to sync. And my expectation is that we're going to have to do this multiple times, like maybe every week for the next 6 weeks. Like as we add new parachains, or as we find bugs, or as we upgrade the protocol. maybe we'll get to the point where we're doing it like once a month. Hopefully by the time we get to incentivized testnet, we'll have this problem sorted out. But I expect there's going to be a lot of restarts of this network over the next few months. And so like we need to remove this bottleneck of Nazar doing all this locally on his machine and having to do like all of these like hacky ways, or like not hacky, but like kind of obscure ways of storing this data. And instead we should have like a node, which is, or not a node, a droplet, which is probably running these same scripts effectively, or maybe even running archival nodes of these parachains in order to get this data in to this seed database. Maybe we could even run on finality instances to do this. They have this hosted service. There's like a lot of different ways to solve this problem. And I'm not by any means suggesting that this is the best architecture that we have. I'm just trying to point out sort of the complexity of this architecture and the problems, the challenges that we've got ahead of us right now. Okay, questions, comments? Nothing, clear as mud, huh? Okay, what do you think, Serge? Are we ready to go like tomorrow, or is this a lot more complicated than we thought initially?
So, well, I can only tell you about my side, and I can give you a quick demo what we have now, if we have time. Do you want to see demo, or I can just describe you?
Before we get into that, I just want to make sure like that we're clear on this, and I'm not just getting like head nods, but we're not clear. So
it's not like crystal clear, but I have a general idea. And I was already working, I mean, into this framework, because I have downloaded RocksDB on BitTorrent, and it took some time. And yeah, I feel like it's not very sustainable workflow. And I'm already running out of space in my machine. So yeah, it would be nice to have something better.
Okay, cool. So I think you're starting to feel the pain of this DevOps workflow that we have right now. Okay. Okay, Leo, you were asking yesterday, should this be a separate instance or should it be on the same machine? And we kind of didn't give you a solid answer. That's why Nazar and I had to have a discussion on this. So what we're thinking is, ideally, Relayer should be a separate machine. So this should be a separate volume, right? And maybe what we can do is spin up Relayer on the same machine to seed it. But then probably the better scenario would be to have multiple relayers, which are on different machines. So I think, yeah, the goal would be to get towards independent instances, but probably to start, we're just going to have this be on the same machine to do this correctly and seed it. And it's probably not worth making it decoupled until we actually know that it works, which we don't know yet.
Okay. Perfect. I will delete the machines that I created then to save space and research.
Okay.
Yeah.
And I think we'll need to scale up the VM that we have for this right now, because it's just 2 cores. It will not be enough.
Yeah, because this is like all one machine right here. So yeah, that's like at least 4 cores. Is that even enough?
Might be on the edge.
Yeah, and then that's like a terabyte almost. It's where, I mean, we're pushing like half a terabyte of space here already. But this can be a separate volume. It feels like the plot should be a separate volume, although that's not really supported within. I guess it is. We could spin it up with a different volume target for the farmer, and then these are like the home directory or like the local directory where it's storing all this stuff. Okay. And who, like, do we have anybody who's like the owner of the maintenance of this instance, or is it shared between 3 or 4 different people right now? Okay, I'd take that as it's shared because nobody's claiming responsibility. Maybe Justin, sort of, when people tell him,
I
ask
think
him to
like
do stuff.
me, Leo, and Justin all have access to it. Maybe they do different stuff there.
Okay. Okay, so that's probably another thing we need to do is like identify like a primary responsible person for this, who's going to handle this. Okay.
Everything I have done is through this Terraform project. So anything related to me is just that. So I think that maybe we should define which tool we are going to use for now to handle all this.
I feel like right now it's probably before, like it's too early to even have a tool because we haven't even identified like what the manual workflow is before we can even automate it.
Perfect.
I think like we should just record documentation so that we're, we know how we're generating these instances or configuring them. And then once we actually figure out the right workflow, we can try to automate it. What do you think, Nazar?
I think there are two parts to this. One is how we run VMs and how we connect volumes, and the other one is what we deploy on it. So we can technically do the setup of the hardware or like virtual hardware in the Terraform, but you can do manual stuff on the instance itself. Just document what we do.
Okay, that makes sense. And how do you have that separated with the Terraform right now, Leo? Is it like the way Nazar described, or is it all kind of bundled together?
Right now, it's all separated, actually.
Okay. Okay, good. Okay, well, let's just focus on the parts that's like the provisioning of the instances and the volumes for now.
Actually, I was working in kind of fast instructions on how to launch an RPC, a public node, and the relayer app. So we at least have that for now.
Okay. Okay, great. Okay, Liu-Cheng, what do you think? Does this make sense? Do you see any ways to fix this or make it better?
Nope.
It's just a mess. Yeah, it's hard to figure out what to do here.
Yeah, I feel that before in checks.
This is kind of unavoidable. You guys had similar problems.
Yeah.
Yeah. Okay. Okay, cool. So let's. I think we understand this problem now. So let's make sure we keep this in mind as we go forward and we try to figure out how we're gonna streamline this and make it better. And then I'll let you take over, Serge, if you want to give an update on the relayer.
Sure. So yeah, as I mentioned, I have downloaded the RocksDB, which is like 40 or something gigabytes, and took some time. But finally, I have implemented processing blocks from the database. So currently, I still use source class and just pass archiver class in the source class and use it internally to process blocks. However, I think better design would be to just make chain archive class and use it like separate instance and forget about source class for processing blocks from archive. So yeah, there are some like design considerations, but currently it works. Just code is a little bit messy, and I can show you. Basically, I created two modes. We have a default mode for relayer, which processes blocks from the RPC endpoint, same as before. And I have added another mode, which is archive mode. So we provide another argument, archive, and the path to the actual archive like this. And if we run, Hope it won't break. Yeah, I have everything running in my background. Subspace node, farmer. Yeah, we need to send balance. Yeah, here it goes. Let's stop and see what we have. So we created the feed. So here in archiving mode, we only have one chain, basically Kusama. We don't have any parachains. So we send one transaction to corresponding account. We create one feed. And we start processing blocks from archive. And yeah, I've been running it before, so I'm not starting from Genesis. And yeah, basically we're starting from 118. So 118 was processed before, and we're starting from 119. And yeah, as you can see, we have 119 processed, 120, 121, and so on. And here are our transactions, and we can go to Polka.apps, reload, and now it will remove. Okay, let's try it again. Let's wait for some events. Yeah. So here are our data submitted events, all from Kusama Relay chain account, obviously. And if we check what is the actual data, so in the original processing from RPC API, if you remember, we were submitting stringified JSON representation of blocks, and here we submit a hex. And yeah, that's it, basically. And we can still use the original one. Same as we did before, but I think it will take some time because we have parachains and it will take time to transfer funds, create feeds. But yeah, you can just trust me, it works as it used to work before. So the question now is, do we have time so I can get things more nice in terms of like code quality and design, or we can move as is?
I have a few questions about how that's working right now. First, so you have multiple. So each substrate transaction or each destination chain transaction includes one Kusama block, right? Okay, and then you're filling up the destination chain, the subspace chain block until it hits the 5 megabyte limit.
No, we check every transaction. Every transaction, like not just the whole block, the data we send, because we have this block transaction data object, which includes the data, the actual block, metadata, signer, and stuff, like everything we need to send transaction. Because we don't only send the actual block to the pilot feeds, we send metadata as well, which can be any data, right? So we check if the total size of this object does not exceed 5 megabytes.
Okay, so the subspace node, its own mempool is determining how many transactions it can fit in the block based on the 5 megabyte limit. It's not something we had to implement.
As far as I understand, no.
Okay, so how many transactions are we getting in a block right now?
I don't know. Let's see.
I'm just curious if we're like actually saturating the block size, or like, you know, what the the throughput of this actually is, because it's going to matter when we're doing 40 gigabytes.
Well, currently, I mean, we just run it for a few seconds, and
Okay.
but currently we have like 10 or 15 transactions per block.
And what's the block time right now? But what's the plot you're using size?
I think it's default 6 seconds. Yeah.
So 6 seconds and 50.
Sometimes it's less than 6 seconds.
Well, it's variable, but it should average out to 6 seconds.
Yeah.
Okay, so 15 transactions
But
for
those
6
transactions
seconds.
like 200 bytes. That's very early in the network. It's very small.
Right, so it should be like 1,000 transactions. Okay.
So I think it matters how quickly we can send them over RPC. So if you like pre-bundle them together, it should go much faster.
So Serge, what's the way that you're communicating? Is it the RPC directly into your substrate node? There's not like an intermediary like in the diagram that I showed before?
No, it's my local node. Yeah, so it's direct communication.
Okay. So you're literally creating the transaction and then sort of gossiping it over the local network. Or posting it, I guess, to the local.
Yeah, I'm submitting, I'm calling extrinsic. I'm submitting extrinsic to the local node.
Okay.
Using a API, polka.js API.
Okay. So I think the next step is going to be to do some sort of like timing analysis of this to see what, like, because 15 transactions seems really, really low for the block size that we have to like. So we need to figure out like if it's the RPCs taking a long time to upload them, like what's the bottleneck or what's the critical path here, or where can we shorten this down? Because at 15 transactions per second or per block, this is going to take like days or weeks to upload, right? Even with these tiny transactions that we have at Genesis.
Well,
tiny blocks.
I think it's not enough data to make any conclusions. We need to run it for like a few hours to make us to have significant result.
I disagree. I think we should be able to know within like 10 blocks, like if we're within like a few blocks, we should know if we're saturating the block size or not, because we're going to get the same results over time. Like if it's not working for the first 10 blocks, it's not going to work for the first 10,000.
Yeah, if it's like orders of magnitude off in terms of number of blocks, it's not a rounding error.
Well, I noticed before that Subspace node starts working slower after like some amount of time if I run it for a few hours. I don't know if you, Leo, had the same situation. Maybe it's like my machine performance, or I don't know, but I noticed some decrease in speed.
It might be like for the first minute or something, but it shouldn't be like thousands of blocks or hours.
Yeah, if you use the default plot size settings, then it should start with an average block time of 6 seconds. I mean, you might get like one that's a second and then one that's like 10 seconds, but it will average out to 6. But even at 1 second, like 15 transactions seems pretty low. Like it should be more like, I mean, if they're like 1 kilobyte transactions, we should have like 500, right? No, that 5,000 transactions included in the block before we hit the 5 megabyte limit. And we're not even talking about 1 kilobyte transactions right now. We're talking about 200-300 byte transactions for the blocks. Unless maybe we're missing something. I don't know. Maybe there's some additional, maybe the metadata, something is larger than we expected, but that's what we need to identify. So, okay. And do we have any way to, okay, so we've got the speed problem or the throughput problem. And then do we have any way to know if the data is actually being written in the order that the nonces are being created, like that the ordering is actually correct? Is there any kind of check for that, or are we just assuming that it's actually going into the mempool and getting included in the feed in the right order?
Well, so far I was just checking logs. According to logs, it's in order.
Okay, okay, that's good. We might just need to double check that as we increase the throughput to see if we're not hitting some sort of a race condition here. Okay, so I think that yeah, the next step is going to be to like identify, to try to really dig into the what's happening here and figure out where the bottleneck is, and then what we can do to speed this up. And we should be seeing something like hundreds of transactions per block, or even potentially thousands of transactions per block, not like 10 or 15. And then I think once we figure that out, then we can let it run for a few hours and figure out, like, look for other bugs, and or hopefully it will just work.
I think I know why we have this delay, because we are waiting for transaction confirmation before we are sending next transaction.
Ah,
You know what I mean? Yeah.
we shouldn't be doing that in this in the seeding phase.
Yeah, I think I'm now thinking about it. So yeah, let me work on this.
Okay.
But this should be not to send like unbounded number of transactions, because we will like run out of memory as they will be pending.
Yeah.
Yeah, that's a good point. There's probably some upper limit on the mempool size that we don't want to exceed, or else we will crash.
I think something like maybe 1,000 or 1,500 transactions in progress should be fine.
Yeah, we can just set a variable and just configure it, just play around with it until something breaks. Okay, cool. So yeah, so Serge, the goal would be to increase that throughput by like 2 orders of magnitude, and then let it run for a few hours and see if we can actually upload the full history, and then just get that deployed for Kusama, like in the production or whatever the test environment that we have. In terms of the like the refactoring to make this better or more elegant. So is that going to allow you to extend it for parachains faster? Or will the parachains work in the current setting? It's just maybe not as clean the way the code is behind the scenes.
If we process parachains from a separate archive, then we need to do refactoring anyway. Because currently, as I said, I just injected this archive into source class. But for parachains, we don't have a source class, so we are using separate class for parachains. So I think it will be more reasonable to just use this chain archive class in this archive mode as a single source, and just maybe like reuse some logic from other classes.
Yeah,
Okay.
we also need to account that when we sync from this archive, the height up to which we synced for parachain and relay chain can be slightly different, because archives are not created at the same instant.
So it should, so as you archive a source chain block, then probably for like a long time, for like, I don't know, 90% of the chain's history, there's going to be no parachain blocks because Kusama just ran by itself. And then we're going to hit a point a few months ago where we're going to start getting these IDs of these parachain blocks, and then those are going to have to resolve to these individual data stores. And it should go like parachain, it should be like relay chain block, and then like blocking, resolve all the parachain blocks like sequentially, and submit those transactions, because we don't want, you don't think so, Nazar? You think they should be asynchronous?
Yeah, I feel like every chain should be in parallel. Then it should be even like architect easier. You just like allow, like basically our relay chain is finalization for the other chain, but they should be like happening asynchronously. They're still like in different feeds, so they don't necessarily depend on each other.
Okay, so individual feeds are synchronous, but parallel feeds are asynchronous. Okay,
Yeah,
that makes sense.
And also, I assume parachains have history before, block history before they became a parachain, right? So we will not have all blocks mentioned in the relay block.
I don't know about that. I'm not sure.
That's a good question. I think it's case by case, actually. I think because you can be an independent blockchain and then upgrade to a parachain. It's a fork. It's like a hard
But
fork.
do you keep the whole history during this transition?
You
Or is
can't,
it like importing states like Chainx did?
like a regenesis.
I think you have to regenesis. Like I thought the Sub-Zero, there is some topic, some presentation on this topic, from a solo chain to a parachain.
Yeah, I don't think I watched that.
Can you share a link to that in the Discord, Liu-Cheng, please?
Okay, I'll try to find you.
Okay, that might be worth us watching. So I think the answer is we don't know, and maybe it depends. But we can probably, for simplicity right now, assume that they match up. And then we'll go in and you know, after we back this up, we'll be able to identify. I mean, I guess it wouldn't be that hard just to manually check, like what is.
I think I have an answer. So when I'm syncing parachains, they have 0 finalized blocks until I get to a certain height. So I already have some finalized blocks from StateMine, and they started being finalized after like 7.5 million blocks on Kusama. So it feels like there was no history before that. Otherwise, they would be finalized by themselves. Like there would be like a consensus on the blockchain itself that can finalize itself. But it's not finalized until it gets to the relay chain. So I think they're like starting from scratch, basically, just importing state.
Okay, let's just assume that for now until we discover otherwise through some error.
So just to clarify, we are processing archives in parallel, right?
Feeds
like
in parallel.
Independently.
But each feed itself, the blocks for a feed have to be blocking and sequential.
Yeah, that's, yeah.
Yeah.
Okay.
Yeah, so there's basically like one sequential blocking process, which is the source chain. And then every time we get a source chain block, then we can do the parachain blocks, but those are all, they can occur independently and out of order between feeds. But then for each individual feed, they are sequential and in order. Okay. Cool. Any other questions, Serge?
No.
Okay. Okay, Leo, I apologize for hijacking the front end app, saying this is just some stuff we really got to sort out right now. So I'm now back to our regularly scheduled meeting.
Well, from the last few meets, I don't have many updates actually. I just want to maybe share the screen and check Notion. there is. Just for you guys to be aware of the current status of the relayer, I have this like the final URL for the Subspace relayer frontend. Like as you can see, it's already connected to the public RPC node. So we don't have feeds still. So this version of the frontend is like ready to start showing information as we have these pending feeds ready, or we start the block importing task. So just to grade this is actually closed and completed, and I will discard this one as I have created this backend in DigitalOcean. But as we are talking recently, it will not be used. So I think that
Maybe you could just put that in the backlog instead of deleting it, because we might want to redo
Okay.
that at some point in the future.
Yeah. So I don't have many tasks in here more than future improvements to the front-end project. So I don't know if have some questions in for now. It's not too much to comment.
Okay, and with the front end, with the Polkadot.js apps, so that's all been approved and deployed
Yeah.
to parity. I don't. Is there anything new to review since the last call, or did we already go over all the
No.
PRs on that?
No, today I will be like writing this problem we have because I was checking this target block time problem, and it's also in a section that is not supposed to be to have code like our own code, right? So in there you have like a function that asks for base expected block time, and if you are not base, it goes and calls another constant that we also don't have because our expected block time is in the api.const.subspace.expected block time. So I don't know how to tackle that because to actually show our block time, we should like insert our own name, right? Our own constant module. And I think that's not allowed in that component itself. So I was thinking in creating this issue and maybe they with a proposed solution actually some
I have
workaround
a
that I have in
question
mind.
there. What if we just copy the line with Babe and just add Subspace there and submit a pull request and see what they reply?
Just that? Yeah,
Like
it's valid that.
you can explain that like this is the only way to do it. There is no like other way to extend it, so we just have to do it. If you have a
Yeah.
better idea, like let's discuss. But it will be
Okay.
like a very direct way to explain what you want to achieve instead of like writing a lot of words.
Yeah, it made me
Maybe they'll
nervous
expand
to do that, but I think it's we don't have another option because I tried to extend the cons or the API and none of them works. So as Nazar said, like adding just the line with subspace, it works correctly actually. So we should do that, and the same history for this another one, or similar history for this other one. So as I have completed the relayer task and it is available in the CDN and connected to the RPC, I was going to focus in these two tasks.
Okay. Yeah, I think that makes sense. Let's just make the direct request to Polkadot or to Parity on how to track these fields.
Yeah, I also was working in like joining some or looking for some documentations and start like a personal database in terms of having this flow covered like deploying the WebSocket with a certificate. So I was working in getting a couple of documents in there, start documenting that internal processes. But just that, I don't know if you have another question.
What else is in the backlog here for Polkadot apps, Polkadot.js?
Nothing else. The last one, there was this another one, but it was really fast to do, so I just made it. It was just activate one action, and it's done. Having these two things completed, I think that in terms of this Polkadot Explorer, we are done. And after that, just maybe start to do the storage API library and start working with the Subspace JS. Yeah, more than that, we don't have any other like goal.
Yeah. Okay. So Polkadot.js is at a stopping point. Do we have any updates to the master branch of Subspace that need to be reflected in Polkadot.js? I know you've been pushing. I guess it did pause a little bit, but you have been pushing a lot. Nazar, are those in sync right now?
I think so. I didn't
Okay.
change anything significant. Not
Okay.
yet.
All right. So Polkadot.js is good. Is there anything for the relayer front end? That any outstanding feature requests or extensions, maybe even if they're not tracked in the board, but anything that we've noticed that we need to change or improve there?
I think that right now, Serge said that the extrinsic will be in hexadecimal format. Maybe that can impact in the way I am getting the data. So I will check that. But
Let me repeat. There is no hex. There is just binary. It's just that you cannot send binary in JSON. So you need to have some kind of representation of that binary, and that's hex in the Polkadot.js case.
yeah, so
But internally, it's
in
just bytes. Shouldn't matter.
shouldn't matter. But just in case, I am every few. When I realize that you have 2 or 3 merge, I just rerun everything. And for now, I have found a couple of issues, and I have solved this in this last pull request that I made, where the object was changed by count in the totals object. So that was actually breaking this count, but it's now solved.
Okay, cool. So you're maintaining compatibility as Serge changes it. Everything's working again.
I am aware that I have to be checking this a couple of from a couple of commits or merges.
Okay. So the next two things on the agenda are going to be Subspace.js and the desktop farmer. Subspace.js has definitely taken priority over that. So we're still going to wait a few more weeks until we have the relayer at kind of a stopping point before we start looking at farmer again. So I think it would be worth starting to work on Subspace.js. Nazar, you had proposed a API in Discord last week, right?
I sent it to the gist on GitHub.
Okay. Have you looked at that yet, Leo?
Yeah, I checked that. I think that is some kind of a structure for the Theories library that will be the storage. So yeah, I am aware of that.
Okay. Are we happy with that as a group? Have you had a chance to look at that, Serge? Do you think that makes sense to you, the way Nazar defined it?
I'm not sure I'm aware of what API.
Subspace.js.
It's a similar gist about regarding like what we done in this offsite engineering when you were programming.
I haven't checked anything. I'm not sure.
It's in a thread in Discord actually.
Yeah, Nazar started a thread where he proposed, yeah, we tried to take it to the next level of proposing what this Subspace JS API would look like.
Okay, I will have a check when I have time.
Okay. Okay, so so yeah, let's do that, Leo. Let's take the template, or I don't know what to call it, the interfaces that Nazar has created, or the kind of the structure Nazar's created there, and start working on extending that. So we have a put side, we have a get side. We really can't do anything with the get side yet because we don't have any retrievability capabilities on the node. So I think about the only thing we could work on right now is the put side of that until we implement retrievability. Right, Nazar?
If we can live with the fact that we need farmer, like access to farmer, someone can actually work in parallel on providing an RPC. I think all the information required is there. It's just like put it together. It is a little bit tricky, but it's doable.
So you mean that Leo could start writing the API, assuming that there's a backend service to call, even though it doesn't exist yet, and then hopefully soon there will be a backend service that he can call?
Yeah, basically.
Okay.
Okay.
Does that make sense, Leo?
Yeah, it's just 2 endpoints. So yeah.
Okay.
Just with parameters, I think I can guess. Yeah.
Okay. So then on the put side, there's basically put object, put object, get object ID, like we talked about, which is going to be composing a lot of the logic that Serge already has in Relayer with regards to how these transactions are written. And then and we're just going to start with this simple object storage, not feeds. Okay, I just want to be clear. We're not doing feeds yet in Subspace JS. We're just doing put an object into the storage.
But we don't have an extrinsic to do it.
Okay.
We only have extrinsics for feeds.
That's another thing we need then is again, so we have
Okay.
to assume that this is going to exist as well. So the use case here is like store NFT metadata, like something like that, right? Just put an object, get an ID out, and then request it by ID, get the object out. It's not the feeds is really a much more sophisticated advanced use case, which we're not trying to support in Subspace JS yet. So the put has to do this, the get, Nazar, are we going to do, in this initial version, do we want to do get piece, expose that on the Subspace JS, or do we just want to do get object and assume the farmer is going to compile the object from the pieces on the back end?
Let's do get object. We will need the logic, like reference logic somewhere. And I think it would be easier to write it in Rust right now. And also, like, things can change, so just for simplicity, I guess. And the farmer is assumed to have everything, so it shouldn't be difficult.
Okay. Okay, that makes sense. We don't really need to have get piece until we have distributed farming, and then the client will compile it. So yeah, so we can just start with the farmer compiling. Okay, so that's pretty straightforward. It's just put object, get object ID, get object ID, return object. Okay. And you're just going to have to kind of assume there's an extrinsic and assume that there's a backend API. And I guess that's actually something that you could probably do, Nazar, is implement that that simple put extrinsic in the meantime, and then we can have Oskin working on the retrievability side.
We can also, in the meantime, we can actually hard code and use the feeds. Like, you just go to the interface, create the feed with index 0, and just hard code in the source code to call that put call. Just to have like end-to-end things working, we can replace the call later. Just so we can click something working in the interface.
Wait, say that one more time. What is the feed?
Okay, so we do not have ownership of the feeds yet. So anyone can submit data to any feed. So you can like go to the Polkadot.js front end, just create a feed, and use that ID in the source code, just hard code it, and just put data in there for development purposes until we have a separate palette.
Okay. So you're saying that's what Leo should do on Subspace.js, is just like replicate the idea that there's a feed with just one ID for one individual object?
Oh, Leo, did you get what I said?
No, just create a random feed and use it.
Just use it once.
Not once. As many times as you want. Just
Oh, so
feed 0, let's say. Feed
Yeah.
0 and you put everything you want.
so there's one feed for all of the non-feed items, basically.
Yeah, until we have a separate palette.
But why do we need a palette? Maybe it can be just a separate call.
Yeah.
Because it's palette feeds, so it would be strange to have
Ah,
a non-feed call in the palette feeds, at least to
fair
me.
enough.
Well, should we just change the name to something like palette storage and make it more generic? Do we need a separate palette between one feed and an item?
It's also an option.
But for now, easier would be just create a random feed.
Okay. Does that make sense, Leo?
Not totally, actually. Where do you want to put this in the Relayer app, in the Relayer front end, in the Subspace.js?
Subspace.js. Subspace.js. So this is, yeah, we're just saying that some of the logic already, like Serge has already created some of this logic in Subspace.js around, or sorry, in the Relayer backend about how these transactions, these storage transactions are created. Okay, I think we probably need to have a separate maybe discussion about this. Maybe we're not at a point where we can start building this yet. So let's keep working on the items that we've identified, Leo, and then we can talk later in the week on the storage API call about Subspace.js in a little bit more detail.
Okay.
Because that really, Subspace.js is kind of storage API more than front end apps, honestly.
Yeah.
Okay. All right. Anything else you want to cover, Leo?
No, I think that's from my side.
Okay, guys, any other questions or comments? All right. Thanks everybody for watching. We'll see you guys next week.